All right, let's talk about something that happens to all of us, probably every single day. Software updates. Why are our apps and computers always changing? Well, today we're going to pull back the curtain and look at the core principles of what's called software evolution. It's the hidden world behind all those update notifications. I mean, you've definitely felt this, right? You just updated an app like last week and boom, there's a new version waiting for you. It's not just in your head, and believe me, it's not always about fixing some tiny little bug. There's a much bigger fundamental process going on here. The best way to think about it is that software isn't like a printed book, finished and done. It's more like a living thing in this huge, constantly shifting digital ecosystem. The second it's released, the world around it starts changing. Your competitors launch a cool new feature. Users start demanding new ways to do things. And yeah, unexpected bugs pop up. If an app doesn't adapt to all of that, it just gets left behind. And this gets us to our first big idea. This constant change isn't a problem, it's actually a core feature of how software works. There's a name for this whole process, evolution. And, just like in nature, it really is the difference between a system that thrives and one that pretty much goes extinct. So, software evolution is basically everything that happens after the big launch. It's that whole long phase where the software is out in the wild, you and I are using it, and it's constantly being updated with new stuff, new functionality, all based on what we need and what the world demands. And here's where we need to make a really key distinction. Evolution is all about growth, adding new value, making things better. Servicing, on the other hand, well, that's just life support. You're only patching up the really critical bugs just to keep the lights on. No new features, no improvements. A system that's just being serviced is only surviving, it's not evolving. And don't think for a second this is just chaos. It's actually a very structured, disciplined loop. Before a single line of code gets written, a change has to be proposed, it's analyzed, it's planned out. This is what stops a simple update from accidentally breaking the entire app. It's that old rule, measure twice, cut once. So what's really fascinating here is that this whole process, which can feel so random to us, isn't random at all. After decades of watching software grow and change, we realized it actually follows some predictable patterns, almost like these unwritten laws of nature for code. This right here is the big one. This is the bedrock idea, and it's captured perfectly by what's called Leemann's first law. It's basically the use it or lose it principle, but for software. The moment a system stops changing, it starts dying, simply because the world around it never, ever stops changing. And Leemann's laws spell out the consequences. As you keep adding more features to keep users happy, the guts of the system, the code itself, just naturally gets more and more complex. It's like adding rooms to a house without a plan. And if you don't actively work to maintain quality and simplify things, the whole system will just get worse over time, as more and more changes are bolted on. Okay. So now we get to the really practical part of all this evolution, the cost. Because this constant cycle of change, which we call maintenance, has a massive financial impact, one that honestly surprises most people. So software maintenance is the catch-all term for pretty much all the work that's done after a program is launched. And what's so important to see here is that it's way more than just fixing bugs. It's also about adapting to new hardware, new operating systems, and, this is the big one, adding all those new features we keep asking for. Now this is one of the most important takeaways from this whole explainer. Just look at this breakdown. A full 50%, half of all maintenance work is what's called perfective maintenance. That's just a fancy way of saying adding new features. Only about a fifth of the effort goes to what we usually think of as maintenance, which is fixing bugs. Most of the work is just evolution and growth. And here is the real kicker. Over the entire life of a piece of software, the cost of all that maintenance can be anywhere from 2 to 100 times the cost of building it in the first place. That is just staggering. Building the software is just the tiny tip of the financial iceberg. So why on earth is it so expensive? Well, a few things are going on. Often, the original developers who knew the code inside and out, they've moved on, so all that knowledge is lost. The code itself, as it gets older, starts to degrade, kind of like a decaying building, which makes every change harder and riskier. And honestly, a lot of the time, the first version was just built to get out the door fast, not to be easily maintained for the next 10 years. So all of this leads to the big million-dollar question for any company with aging software. Given how high the costs are, what do you do? Well, you've really got a few main options. You can try to revive it, you can re-engineer it, or you can just scrap it and replace it. Re-engineering is kind of like a major home renovation. You're not adding a new bedroom, but you're ripping out the old plumbing and wiring and replacing it to make the house safer and easier to live in. For software, this means totally overhauling the internal structure to make all those future updates way cheaper and faster. Refactoring, on the other hand, is more like preventative medicine. It's not some huge project. It's this constant process of cleaning up the code in small, manageable ways as you go. You can think of it as just tidying up the house a little bit every day so you don't need a massive, super expensive cleanup project down the line. So here's the difference in a nutshell. Re-engineering is the major surgery you have to perform after things have already gotten really bad. Refactoring is like the daily exercise and healthy eating you do to try and stay healthy and avoid that surgery in the first place. And how do developers know when it's time to do this stuff? Well, they look for what they playfully call code smells. These are just warning signs that the code is starting to rot. Things like finding the exact same block of code copied and pasted in 10 different places, which means if there's a bug, you have to fix it in all 10 places. Or finding a single function that's 1,000 lines long and is impossible for anyone to understand. These are the signals that say, okay, time to clean this up. Ultimately, the big decision all comes down to a strategic choice, kind of like this grid. You look at a system on two axes. How good is its quality, and how important is it to the business? A high-quality system that's also super valuable? That's a keeper. You just keep maintaining it. But what about a low-quality system that's absolutely critical to your business? Well, that's your prime candidate for a big re-engineering project or maybe even a total replacement. And if it's low quality and not very valuable, well, then you just scrap it. Okay, so that was a lot. Let's wrap this up by boiling it all down to the core principles we've covered today. So here are the 4 big ideas to walk away with. First, change isn't just common, it's essential for software to even survive. Second, this change isn't random, it actually follows these predictable laws. Third, and this is a big one, maintenance and evolution is where the real money is spent, way more than on building it initially. And finally, companies have to make these tough strategic choices about their old software based on a really clear-eyed look at its quality and its value. So the next time you see that little notification and you tap that update button, just remember what's really going on under the hood. Sure, it might be a simple bug fix, but more than likely, you are witnessing one small move in a continuous, incredibly complex, and fantastically expensive battle to keep that piece of software alive and useful in a world that simply refuses to stand still.